as well. All right, so I'm going to start right at the top here. Doesn't it feel like Friday? Really feels like Friday. Okay. So an arithmetic sequence is going to use your addition and subtraction. And in addition to that, your arithmetic sequence is going to follow more of a linear model. And what you've also seen in the past here too is this has a common difference denoted with the letter C. So I wrote all your formulas out for you just to make your life a little bit easier. So that is the explicit formula that is used to find a specific term of an arithmetic sequence. Is it familiar? Perfect. Yep, you worked with it a lot last year, and then you did some stuff with it in your Algebra 1 course as well. So number one, you want to find the next two terms of this sequence. And I want you to practice with the formulas. So I'm going to make you do the formulas for everything too. And then obviously when you get to homework, if it's a really easy one, you can kind of just use your pattern. So I want the next two terms. So I'm looking for here, do I have a common difference to get from term to term? Yes, +5. So this is arithmetic. Your reasoning is because this has a common difference. So arithmetic difference is equal to, again, +5. So if you want to find the next term, so I am looking for term number 4. I'll let you just do this one the easy way. You don't have to write a formula. So you're going to add 5 to this and you're going to get 8. And then you're going to add another 5 to this and you're going to get a 13. Yep, just like that. So you're just looking at your pattern. Number 2, however, do you think that it would be a good idea to use the pattern or the formula? Probably. Yeah, probably the formula, because if you're looking for the 41st term, there's a lot of chances that you'd make a small error somewhere in the middle there. So this case here, I want from 11 to 4. So I'm going to do what this time instead? D is equal to, yep, I heard it, subtract. So you're going to go -7 instead. So you're going to take this and you're going to write your formula. So I know that A sub 1 is equal to 11. And you're going to write your explicit formula because that's used to find a specific term. So I'm going to go A sub n equal to, we're going to go A sub 1 plus D and then times n minus 1. All right, I want to find the 41st term. And again, these are all subscripts. So A sub 41 is going to be equal to, so A sub 1 is 11, and then minus the 7, and then you're going to substitute in 41 minus 1. All right, so A sub 41 is equal to 11 minus 7 times 40. And at that point, you can just type it in the calculator. So what is this? 11 minus 7 times 40. Negative, yep, 269. Perfect. Negative 269 would be that term. Okay. Easy so far? Yeah, it's pretty much just review today, mostly anyways. So number 3, you want to find the first term for this sequence. So you're kind of working in reverse here. You're going to go right to your formula, and we're going to go A sub n equal to, and I have A sub 1 plus, and then I'm going to go D, and then n minus 1. All right, so I have the 44th term here. So we're going to use the 44th term. So I'm just going to put that in here first. So this one we're not going to know. The D we are going to know. And then this is going to be a 44 as well. And now all I'm going to do is replace this side with 229. And this is equal to A sub 1 plus 8 times 43. And what is 8 times 43? 8 times 43 equal to, yep, thank you, 344. So I have 229 equal to A sub 1 plus 344. you are going to subtract that over. So I have a sub 1 equal to something here. All right, so 229 minus 344. I got negative 115. All right. So your next vocabulary term here is called an arithmetic mean. And these are just going to represent the terms between any two non-consecutive terms. So you're going to be looking for the middle here, essentially. So you would like to form an arithmetic sequence that has 6 means in between those two values. This is how I like to do these. You're welcome to use whatever strategy has kind of worked in the past. So a sub 1 is equal to negative 12. And I want to find all 6 in the middle. So I want to find a sub 2. I want to find a sub 3. Just again, make sure those are subscripts. And then a sub 4, that's 3. Here's the 4th one. And then here's the 5th one. 1, 2, 3. Here's the 6th one. And you're given the 8th term. All right, so your 8th term is equal to 23. Okay. And with these today, it really just depends on how well you are at noticing patterns or not. Some people are better than others. Some people really struggle with figuring out, you know, what would be a constant value that we add to this. So I'll give you formulas for everything just in case. So I need to figure out what my D is here. So I can use that formula to solve for D. So I'm going to use my explicit formula to solve for D. So use explicit formula with the intention of finding your D value. So I'm going to go a sub n equal to a sub 1 plus D times n minus 1 and sub n. So a sub n in this case is going to be the 8th term of my sequence, 23. And this is equal to a sub 1, which is negative 12. The D value you don't know, so I'm going to leave it as D. And then you're going to go n minus 1. So that in this case would be 8 minus 1. All right, so add that over, we get 35 is equal to 7 times D. And then you're going to divide by 7. Divide by 7. So D is equal to 5. So now what you can do is use that pattern and you can fill in everything from your sequence. All right, so what do we got here? So negative 12 plus the 5 give me negative 7, yep, plus 5 again. So negative 2 plus 5 again, that would give me 3, plus 5 again would give me 8, plus 5 again would give me 13, plus 5 again would give me 18. So you're just taking your sequence and building it like that. Okay. So the next formula that you've been exposed to in the past is the formula for the sum of an arithmetic sequence. This is the one in Algebra 2 that you were told you had to memorize, and it would never be provided to you on a formula sheet, which is true, it isn't. The geometric one is, but the arithmetic is not. So S of n stands for your sum, and this is whatever number of terms that you have in this case. So this stands for sum. N obviously stands for the number of terms you're finding the sum of. So this n is the number of terms you are finding the sum of. Finding the sum of. A sub 1 is obviously your first term. And a sub n is one that you often have to go off to the side and find first. This represents the last term. So this is your last term. So And number 5, I need to find the sum of the first 32 terms of this sequence. So I'm going to start and set up your formula and see if we have enough information or not. So the sum of the first 32 is going to be equal to, so I do the 32 again. Do we have the first term? Yes, negative 12. Do you have the 32nd term? No. So in a second, we got to go find it and then divide it by 2. So I need to find that first. So I'm going to go off to the side here and write down a little note for you. You need to find a sub 32 first. So you're going to do your formula. So a sub n is equal to a sub 1 plus d times n minus 1. All right, so I want the 32nd term equal to, first term is negative 12, and then common difference would be just plus 6, and then I'm gonna go 32 minus 1. You can type that in the calculator. You don't have to do all the algebra if you don't want to. So I have negative 12 plus 6 times 31, and that is equal to, did you guys get 174? Awesome. So a sub 32 is equal to 174. And this is going to get placed right here. This is 174. You can compute this on your calculator all in one step. So what you're going to do is I'm going to type. So I'm going to go alpha y equals enter. And we're going to type in, it was what, 32. And then parenthesis, the first term was it negative 12? Negative 12, and then plus 174. And you're going to divide this by 2. Again, as long as you type it like that, you can do this whole thing all at once. So this is equal to 2,592. 2,592. I'm trying to remember that. So the sum of the 32 terms is 2,592. All right, how's that formula? Pretty good? Mm-hmm. And you have to find the first term? Yeah. Hold that thought. Oh, that one we have, but you are missing something else. Okay. So yes, you'll be missing other information. That's exactly what you're asking. So now what you have to find instead is your n value here. So again, something's missing. So I'm going to start this and go. I know the sum formula is equal to, and I've got n, and this is going to be a sub 1 plus a sub n, and then this is divided by 2. I'm going to start and plug in what we know, and then you're going to have to kind of go off to the side and find what you're missing. So the sum is equal to 440. I do not know n. A sub 1 is equal to 5. And do we know the last term? No. And then this is divided by 2. Okay, so you have 2 unknowns and you can't have that. So I'm going to go off to the side and I am going to find a sub n. So you're going to do the formula. A sub n equals a sub 1 plus d times n minus 1. So a sub n is unknown. A sub 1 is equal to 5. D is equal to 3, and this is n minus 1. Don't know it. That's okay. So a sub n is equal to 5 plus 3n minus 3. Therefore, a sub n is equivalent to 3n plus 2. And that is actually what you're going to substitute over here. So we're going to put that in there. So I'm going to have 440 equal to n, and then 5 plus, and then 3n plus 2, and divided by 2. So keep going. You got to work with this one. Let's get rid of the 2. So multiply 440 by 2. I get 880 equals n, and then this would become 3n plus 7, and then distribute. So 880 equals 3n squared plus 7n. Yes, this one gets a little bit tougher. This is a quadratic equation. So kind of like you factored at the end yesterday. So what does this need to be equal to? 0. Yep, so 880 is going to move to the other side. I get 3n squared plus 7n minus 880 equals 0. Now, there is nothing in this question that states that you must do algebraic work to get this answer. So I guess I'll give you guys the option. We can do factoring, or I can show you the fast way to get this on the calculator. What do you prefer? Fast way. Okay. So go to your y equals. So I think you have a homework one that works like this too. And you're going to type in 3x squared minus minus what was it? I'm sorry. Plus 7x. Thank you. Appreciate that. And minus 880. Okay. And what you're looking for are your roots. Don't even bother hitting graph, but go to the table instead. And what you're looking for on your table, if you scroll, is your place where you are at y equals 0. You guys see it? Right at 16. Yep. So that is your value of n, and that is your solution. So again, that's the fast way to do it. So n would be term number 16. But let me write a little note for when you go to look back at homework so you know what we did there. So instead of factoring, which you could obviously do too, so we typed into calculator, obviously y equals, I should probably state that, y equals, go to table and find where y is 0. So go to table and find where y is equal to 0. And that was located at 16, but I'm going to use an n instead because it's a sequence. So n is equal to 16. How's that one, okay? Perfect. Does that kind of answer your question? Yes, you just have to kind of work with it algebraically off to the side and then fill it back in. Like you read my mind there. All right, your next one. This is what's called a harmonic sequence, and it's made up of the reciprocals of an arithmetic sequence. And there's a typo, so I need to have you fix it before we get a problem that's not going to be possible to do here. I fixed it here, but I don't think it's fixed on yours. This number, does it say 1 over 14 or does it say 1 over 4? 4 over 4? 1 over. Change it to 1 over 14, please. I'm sorry, that was my fault. I went too quick. So this is a typo. And again, just change this one right here and make sure that it does say it needs to be 1 over 14. I caught it when I put it up here, but I didn't catch it when I copied your notes. So harmonic is going to involve the reciprocals, okay? So if you have a sequence 1, 2, 3, 4, it's a harmonic sequence if you can take those reciprocals. So you'll see your little pattern like this. So again, in your head, you kind of want to keep thinking, is there a particular pattern? And if you can see the pattern, then you don't really have to show any algebraic work. But if you struggle with that, then you might want to. So I would like to find the sixth term of a harmonic sequence if the first and fifth are respectively 1/2 and 1/14. So I'm going to write these out again, just because this is how I like to do them. So I have a sub 1 equal to 1/2. And term number 2. And term number 3. And term number 4. And term number 5. I think we were given 5. Yes, that's 1/14. And term number 6, you are looking to find, and you're probably going to need the ones in the middle anyways, but it's good practice to find them. Okay, so again, some of you might be able to just eyeball this. What you're looking at is your denominator, and you're thinking about what are we adding to each one of these to get from 2 all the way to 14. And you could absolutely start with like try plus 2. So that would give me a 4th, a 6th, and then 1/8, and then obviously I don't hit 14. So then go to 3. So we would get 1/5, 1/8, 1/11. Does that work? It does. So if you can use that, then go for it. That's fine. If you can't, look at your 14, look at your 2. So I would go 14 minus 2 is equal to 5 minus 1, so 4 times D. So 12 is equal to 4D, so therefore D would be equal to plus 3 on the bottom. But again, you don't have to show that work if you're really good with pattern-based content. So my answers now are going to be 1/5, 1/8, 1/11, and lastly would be 1/17. Okay, so you're just looking at your reciprocals there. So same deal with this one. And again, if you can eyeball this, that's fine. So I'm going to start and write out my first term, which is equal to 1/5. And I want to find 3 harmonic means just in between. So a sub 2 and 3 and 4. And we are looking for the, oh no, we have the 5th, sorry. So 1/17. If you can eyeball this pattern, go for it. If you want a concrete formula that works every time, it's the same thing as I did above. 17 minus 5 equal to 5 minus 1 would be 4D. So I get 12 equal to 4D. Is it the same pattern? Yes, it is. So D equals plus 3. So I would have 1/8 and 1/11 and 1/14. Okay, so just like that. How are those, okay? Just kind of looking at your reciprocal, and then to get that pattern on the bottom, you were just looking for what did you add on. So the second type of sequence that you learned about in the past is called a geometric sequence. This uses multiplication with a value of R, which is called a common ratio. What characterizes this one instead is it's going to follow an exponential model. Anything you guys get as decimals, please just hit math, enter, enter, and change them. So that is your explicit formula instead. And I gave you a formula for your ratio. And again, this is just in case you're not great with patterns. This always works. So your common ratio is always your second divided by your first, and then you could check your third divided by your second as well. So number 1, I want to find a sub 12. So I'm going to write a formula here instead. So I'm given that a sub 1 is equal to 1. And then what is my R value here? What am I multiplying by? I think you can tell. Yeah, good, just 1/2. Again, that one's kind of nice and easy. So now I'm going to do my explicit formula for a geometric sequence, which looks like this instead. So I have a sub 12 I'm looking to find, equivalent to a sub 1 is 1. R value is 1/2. and this gets raised to the 12 minus 1. You can type the whole thing in the calculator. If it gives you a decimal, could you please kindly change it back to a fraction? What does this come back as a fraction? 1 over 2,048. Did you guys get that too? So right into your calculator, and again, math enter if you need to. So number 2, we're gonna find the terms in the middle, just like before when we did the arithmetic. So I wanna go 2 geometric means between 128 and 54. So I have a sub 1, and that is 128. And 2 in between. So a sub 2, a sub 3, and then I want to go all the way to the 4th. I think typically these are harder to eyeball the pattern for. I mean, if you can do it still, that's fine. I think you would probably want to write a formula to find R. So if so, we're going to do, so find R. Your explicit formula with R basically unknown. So I'm going to go a sub n equal to a sub 1 times R to the n minus 1. So a sub n in this case is going to be my 4th term of my sequence. I'll do this first. Here's your notation. And then this would be to the 4 minus 1. And then I'll sub in. So I'm going to get the 4th term is 54 equal to 128, R is unknown, to the 3rd. Divide by 128. Divide by 128. I've got 54 over 128 equal to R cubed. And how do you undo a cube? Cube root. Yep. So cube root, I'll show you on the calculator in 1 second, but we're going to write it first. And then cube root 54 over 128. All right, so in your calculator, just in case you forgot, things happen. So you're going to go to your home screen, you're going to hit math, and your cube root feature is right here. So choice 4, and it was what, 54 over 128. Enter. And then, I mean, that decimal would be okay to use. Or if you want, just math enter. Or hopefully you just know that that's 3/4. So ratio here is going to be equal to 3/4. Then what you're going to do is take that value to find everything else that you're missing. All right, so 128 times 3/4 is how much? 96, thank you. So this was 128 times 3/4, just in case you want the work. Can someone do one more, please? What's 96 times 3/4? 72, thank you. And then there you go. So there's your missing terms. How's that, pretty easy? Okay. Again, you've seen it before. You're just working with those formulas. Which brings us to your formula for the sum. All right, so now I want the sum of a geometric series. This is the one that's always provided to you, but I mean, I guess for your purpose this year, you don't have to memorize things anyways. But the geometric formula does not use the last term. It's going to use the first term and it's going to use your common ratio. So it's a little bit easier to do. So I want to find the sum of the 10 terms of the series. So I am given here that a sub 1 is equal to 2. And my R value is equal to -3. And then I'm going to just sub in. So the sum of the first 10 terms is equal to a sub 1 is 2 minus 2. R value is -3. And this is raised to the 10th. And then divided by? 1 minus -3, or obviously just type in plus. Okay, so that goes right in the calculator again. You're going to just use your alpha y equals key, type it in. And what do we get for that one? So I got negative 29,000. And 524. Expect your geometric ones to be larger and really small answers as well, just because it follows that exponential model instead. Okay, so number 2, find a sub 1 here for the geometric sequence given an R value and given the fifth value. So now you're not using your sum formula anymore. You're going to use your explicit formula instead. So I'm going to go a sub n equal to a sub 1 times r to the n minus 1. So I have a sub 5 in this case that's given. And then a sub 1, and then r, and then 5 minus 1. And you're going to sub in. Fifth term is 64 radical 2. And the first term is unknown. And the r value is the square root of 2. And then power to the 4th. Try this first in your calculator. This is nice. I'm trying to remember what it is. Is it 16? Square root of 2 to the 4th? Or was it 4? 4, thank you. No, I was close. So 64 radical 2 equal to 4 times a sub 1. And then you're going to just divide by 4, and then you're good. So divide by 4, divide by 4, and we get what? 16 radical 2? Yep, equal to, what was this? Our first term. So that is your solution for term number 1. All right, so number 3 was just a calculator thing I wanted to kind of show you. We'll do more with this next week too. This is your symbol for a summation. So it represents a condensed sum. And what this means is you start at n equals 1 and you would substitute values from 1 all the way to 7 using integers. And if you did this by hand, you would take them all and add them up. Well, your calculator will do this too. You remember where to find your summation symbol? Probably not, that's okay. So you can always find everything right in your catalog. So to get the catalog on the calculator, what you're gonna do is hit second, number 0. And instead of scrolling all the way down to the S's, you can shortcut this by hitting alpha, alpha, and then S, which is your natural log key. And it's gonna hop down to the S's for you. And unfortunately, now you have to scroll. So you are going to find the summation symbol. Hopefully you've seen this in the past, but probably just really briefly last year. If at all, some teachers don't show it and make you just do it by hand. So you want to use this one right here. So summation, and then it has your symbol, your sigma symbol already started, hit enter. And on the bottom, use X instead. X was equal to 1. And above this, we went all the way to 7. And then over here's my formula. So I'm going to go 200. And then I'm going to go parenthesis. And then I'm going to go 1.01. And then I'm going to go raised to the n minus 1, which in our case is going to be x minus 1. And I'm going to go x minus 1. And I need another parenthesis to end this off, though. See if I can get back down. You guys get an answer? I could probably just go like this, actually. Will that work without the parentheses? It really depends on the calculator you have too, usually. And then hit math, enter, enter. It does not clear that up. All right, hold on. Enter. I'm going to throw my parentheses in here. So I'm going to go second insert. Gotcha. Thank you. And you know, it really depends on which version of the calculator you're working with. Like on our older versions, you could type it in how I'm doing here. But if you put your exponent inside, Jeb, did you get an answer? Yep, that's correct. So I'm going to do this. I'm trying to grab that back down here. Yep, so exponent inside. I'll have you just write that instead. That's probably easiest. So when you go to type it, so make sure that this is located inside. So I'll say on calculator. We're gonna do a ton of those next week. So if you didn't just get that, don't panic. I don't even think I gave you any on homework just yet either. So it's just to kind of meant to show you that you do have one of those on there. You just access it right from your catalog. Parentheses are on there too. And then that answer worked out to be 1,442 point, I don't know, we'll go nearest 10, 7. Okay, so summation, accessible right through your catalog. We'll do it again next week too. All right, so to finish, what you can also see with your sequences is you can see pattern-based ones. So here are some common ones I listed for you. And again, it's obviously not your full list here. The one that I think you're probably the least familiar with is what's called a factorial or a factorial. And it's this symbol here. Do you guys remember doing that in probability like a long time ago? Yeah, it's probably been a couple of years. So if I do a factorial, like if I have 3 like this, what that represents is 3 times 2 times 1. And it comes up most often in probability. Like if I had I'm not going to get big here, 4 factorial, I would go 4 times 3 times 2 times 1. Am I coming back to anybody? Okay. It is another pattern-based application as well. So this 1 would just represent 1 factorial. The 2 would be 2 factorial because 2 times 1. Your 6 would be 3 times 2 times 1, and your 24 would be 4 times 3 times 2 times 1. So that is another pattern. That one's a little bit harder to tell just because you're probably least familiar with that. And then powers of 2 and then cubes as well. So cube, obviously this one, you would just do like 1 cubed and then 2 cubed is your pattern, and then 3 cubed is your pattern, so on and so forth. Okay, so you want to look for those as well. So your last section here is what we're going to do is classify these as arithmetic, geometric, or the harmonic with the reciprocals. Always check your arithmetic first, unless something kind of jumps out to you. So letter A, can I use addition and subtraction to get from term to term here? Well, again, because these are fractions, sometimes you want to actually look at this. So if I do 1 over 16 minus negative 1 over 32, what do I get? And is it the same value as the third term minus the second term? So try that first. Use your calculator. So 1 over 16 and then minus negative 1 over 32. Math, enter, enter. I got 3 over 32. Next, 5 over 32 and then minus 1 over 16. Math, enter, enter. What do you guys notice? 3 over 2, 32. It's the same. So this is just arithmetic. That's your common difference. Yep, that one works. Letter B. Is letter B going to be arithmetic? No. So check geometric. So is this geometric? Check your R value. So 4 divided by 32. What do I get? And is that the same thing as 1/2 divided by 4? Again, unless you're really good and can just look at this, that's the formula you want to use. So 4 over 32, math, enter, enter, is 1/8. And then 0.5 divided by 4 is also 1/8. So this is geometric because it has a common ratio of the 1/8. And then this was your difference, just in case you want those. Okay, now letter C. I've got some fractions in here. This is obviously not going to be the arithmetic. So I'm going to look and see if I can do something with reciprocals instead here. So I'm going to see if this one is harmonic first because it doesn't appear to be the others. So that means I'm going to flip these. So this 8 would become a 1 over 8 like that. If I take the 4 and flip it, that's going to give me a 1/4. Hold that thought. Take this one and flip it. That's a 3/8. You're looking for patterns here. Well, what can I rewrite 1/4 as? 2/8. And if I can do the same thing with the 2, then this is harmonic. So the 2 is a reciprocal, would be 1 over 2. And how can I write that in terms of 8ths? Exactly. So you just have to kind of rework it a little bit and look at the fractions that are already there to figure out your denominator. So yes, that works. So this one is harmonic. And then last, let's see if you can do the same thing because you've got all those fractions again. So letter D, if I take the reciprocal of 6/5, that's going to give me 5 over 6. And my next one would give me 7 over 12. And then my next one, so 3 over 1 would become 1 over 3. And then 12 over 1 would become 1 over 12. So if you look, your reoccurring denominator here is a 12. So see if you can change these. So 3 in terms of 12ths would be 4 over 12. And then how about this one, over 12? And now look at the top. Is there a pattern? Yep. You went 10, 7, 4, and 1. So yes, this is harmonic as well. But again, you just have to use your reciprocals and you got to sometimes change your denominators around to help you see that. All right, how do we feel with the arithmetic, geometric, and harmonic? Pretty good? Okay. So again, tomorrow's going to be your day to complete some work. So feel free to bring headphones and your Chromebook if you'd like to. Or you can obviously, I would prefer you talk to people.